Hi, I'm Wu, and I'm gonna record a video for question number 1 in homework 5 for the course probability and stochastic processes. So the question is right here. It offers us the fx, x, and fyy, and they equals to xy, and it requires us to find fzz by two methods. First is convolution method, and second is geometric method. So we're gonna begin with the convolution method, and the question has offered us the equation to find out fzz, which is equals to fxz convolute fyz, and equals to differentiation of fx alpha times fy z minus alpha times d alpha. So to begin with this question, so since fx x is start from 1, so we want it to begin with start from 0. So we're gonna set fx equals to ux minus 1, which can make this become simple. So this is a diagram for fxx. So it becomes a uniform function and it starts from 0. And this is fyn, which is also in an uniform function. So we convolute these two functions so that we can get fzz, which will be look like this. But we're gonna use the convolution method to calculate this graph. So it equals to fxz convolution fyz, and equals to this equation, which is given by the question. And since we already know that fx equals to this one and fyy equals to this one, so we're gonna substitute y with alpha and x minus 1 with alpha minus 1, and also the y with z minus alpha, and y minus 1 with z minus alpha minus 1. And then we're gonna calculate this, so which is equals to this equation. I'm gonna save time, so you just time this out. So, and then we get this equation, and finally we can calculate this one. So it's z times uz minus z minus 1 times uz minus 1, and minus z minus 1 times uz minus 1, and plus z minus 2 times uz minus 2. So then we're gonna show the diagram for this equation, which is fzz. So first, the first is z times uz, which is this line. And first we're gonna do this part. So, and then z minus 1 times uz minus 1. So it starts from 1, and it also is a straight line. So it will be like this line is z minus 1 times uz minus 1. And then we're gonna use this and minus this. So in a part that from 0 to 1, it will keep the shape of z times uz. And then in this part, in a part which is when they larger than 1, it will be a straight line, and it will maintain its value as 1. So it'll be 1. And then we're gonna calculate this part. So this line is the same as this line. So it also look like this, and we got this line right here. We're gonna use this to minus this line, and then we can get this line. So it's z times uz minus 2 times of z minus 1 times uz minus 1. And then we're gonna add the last part, which is z minus 2 times uz minus 2. So it will start start at 2 and will be like this. So these two part cancel out and become 0. So the graph will look like this, and then it will maintain the value of 0. So since we start a problem with fx equals to ux minus ux1 minus 1, but the question offers us that fxx which is ux minus 1 minus ux minus 2. So we're gonna shift the whole graph to right by just 1 unit. So the final answer of fzz is this equation right here, and its graph will be look like this. We shifted this graph to right by 1 unit. So, and then we're gonna do the second question using the geometric method. So we start these questions by setting that fx equals to ux minus 1. So that makes this question become easier. And then the fzz is equals to probability that that z minus z less than or equal to little z, and which is equals to the probability of x plus y less than or equal to little z, since the question also told us this information. So I'm gonna divide this question into 3 situations. The first is when z less than or equal to 1. So that the probability, which is the area of this part, which is equals to z squared divided by 2, since this area is a triangle. So we can get that. And then we can use this to get the little fzz. So it's just a take derivative of the large fzz, so which is equals to z. And then in this situation that z is larger than 1 and but is smaller or equals to 2, so the z will be larger than 1, so the shadowed area will be the large right triangle minus these 2 small white triangle. So it will be the z squared divided by 2 minus since there are 2 small triangles, so it's 2 times the z minus 1 squared divided by 2, and then we can get this equation. And by taking the derivative of this equation, we can get the little fzz, which is equals to negative z plus 2. And the last situation that when z equals to when z larger than 2, so the shadow area will be this square, so the area will be 1 times 1, which is equals to 1. And we can take the derivative of this equation, so we get 0 LS. So combine all these situations, we can get the diagram of fzz. So, and then since we start a question as the fxx equals to ux minus 1, so we also need to shift the whole diagram to right by 1 unit. So so in the final we get the diagram look like this, which is equals to which is the same as the diagram we found out in question 1. So we can prove that we calculated right. So thanks for watching.